Good morning. We are your teachers for today. Chemistry.
Mr. Bushdiker has fallen mysteriously ill, so today we are substituting for him. So, today we're going to be talking about the rates of solubility, how they increase and decrease. The 4 ways to increase it are temperature, surface area, agitation, and pressure. We're going to be starting off today by talking about how temperature can increase the rate of dissolution of water and sugar. Andrew, take it away.
So today we're going to be talking about how temperature increases the rate of solubility. So what happens when you have a solid is intermolecular forces keep it tightly packed together. So when you increase the temperature, it makes the molecules move really fast, which allows time for water to come in and rush in and pull it apart.
These are the molecules of a solid, for example. This is a very bad drawing, so don't judge us. But
You can judge him, it's fine.
These lines represent the molecules pushing out at each other, and whenever you add temperature, they're moving even more, faster and further, pushing each of the molecules apart, which eventually just dissolves into a big mess of water.
And the space between them, since they're moving so fast, there's more space in between it, which is why water can come in and dissolve it and pull apart the molecules even faster.
Speaking of space, the next topic is surface area.
What have you got?
The next topic is surface area. The surface area increases the rate of dissolution because because it causes more collisions, of course. But if you were to have a block of salt, as my colleague Andrew is drawing, the water can only dissolve it from the outside to the inside. But if you were to have broken up pieces of salt, it would be a whole lot easier since there's much more reactions with water. You see,
So since there's a block here, it has to work from the outside and come in. And so over here, it can work on each one of these at the same time. But since there's just one giant block of salt here, then it has to just move on the inside. But with this one, it works on all the tiny ones, and so it dissolves it faster. Poof, gone. The drawings are gone. How cool is that? All right.
very cool, Andrew, very, very cool.
Thank you so much. All right, so this is how the next increasing of the rate of solubility works.
Marker, please.
Yes, agitation. So agitation is, in the essence, stirring around the molecules. So if you have sugar in a glass of water and you stir it around, it increases the solubility. Why? Well, it's simple. So what happens is when you stir it around, it moves around the cup. And so it gets introduced to more water molecules. And so this, in effect, increases the rate of solubility. It's much like when you're on a carnival ride and or the Texas skyscraper at Six Flags, right? I'm not crazy?
No, you are not crazy. That's what I'm drawing right now.
Okay, yeah, I've only been to Six Flags once, So when you get spun around the Texas skyscraper, you're getting introduced to more air molecules as you're crying for death around the Texas skyscraper. And so that is the same principle as stirring sugar molecules in water. What next, my dear fellow?
Well, next we're going to be talking about a special solute, and that is gas. Gas dissolves in water by adding pressure. You see, there's always going to be gas above the solvent, and to get that gas into the solvent, you have to add pressure to it. And the more pressure you add, the more gas is forced to come in contact with the solvent, which of course creates more collisions, as we all know, and that increases the solubility. Just think of a can of Pepsi, and whenever they carbonate it, they add pressure to it, and it just pushes the gas down into the solvent, and it soaks it up. And then they bottle up, and all that pressure stays in there, so it's, you could say, dissolved gas is dissolved in the liquid. But whenever you open up that can, all that pressure is released, so all that gas is starting to come out, which is why we drink them so fast, and it's also because they taste very good. Andrew, I said Pepsi.
Yeah, but Coke is better.
What do you mean?
Coke is obviously the more superior.
No, listen. Coke is not the most superior soda. Pepsi is so much better.
Are you literally joking? I can prove this with science.
Mr. Bushtalker, through that phone, will tell us if Pepsi or Coke is better. Mr. Bushtalker, which one's better?
Coke. 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 Coke.
This concludes our mastery project.